I'm very honored to be here. I'm today bringing you an outside view to AI and sports as a computer scientist, as a researcher in artificial intelligence. My research is in pattern recognition, deep learning, and something that concerns me is the stuff we are doing in AI and developing these technologies in our niches, in industry, in sports, in different fields. How is it in the long term affecting our societies, the way we live in the future? And that's the outside view I want to bring you today. Is what we are observing, for example, in sports, can it not be seen as a microcosm of things that could play out at large in society in the future years? So that's the idea I want to explore with you in the next 30, 40 minutes. Are you with me? Fantastic. So AI has changed the game in many, many ways. And one example of it is what we see here from the NBA. Apparently, before data analytics was launched largely and the Moneyball game started to play out, players were shooting from everywhere to hit the basket. But since we can actually analyze what is worth attempting and what not, we see players now know they either do the three-pointer or they go to the basket and do a slam dunk. Everything else is basically just not worth it. The game has changed. And it has changed because of AI and analytics. And that can be a very cool thing, a very good thing. For example, here in tennis, I got that from a company called TennisWise. They say we can, for example, use wearables to track what athletes are doing, and we can use it to better train them, help their fitness, help them prevent their injuries, which is, of course, very, very important. We can use data to help them train their mental fitness. And we can use all of this, and not just in tennis, to enhance the tactical understanding and to better game preparation. So there are a lot of upsides in for AI in sports, not just for the sports themselves and the athletes, also for the engagement of fans by having the best social media campaigns to engage them in the game, to make them see everything possible about their favorite team and players. And it's also a great thing for fairness. The older ones probably remember the game. That's, of course, John McEnroe. And one of his famous meltdowns, just because he saw the ball in, and the referee did not.
You can't be serious, man. You cannot be serious! That ball was on the line! Shot flew up!
There are unfairnesses in sports that happen due to our human imperfections, and AI can help with these. How can it help with these? Well, for example, by having an automated eye looking at the lines and helping the referee and seeing if the ball is actually in and out. Wimbledon just changed their rules. They now have a camera system on board that will actually help referees to see if the ball is in or out. But apparently, such a technique is not perceived similar in all different kinds of sports. So this is, of course, a picture from Germany, where it's all about soccer, and not so much about tennis, since Steffi Graf and Boris Becker are not playing tennis anymore. And this is a couple of fans showing the officials what they think about the video-assisted referee. They actually don't like it at all. They actually compare it to playing Russian roulette. Why? Because not because it's not analyzing correctly its decisions, but because it is perceived by the fans very, very random when this video-assisted referee actually is engaged and challenges the decision of the referee on the field. And actually what they say, the organized fans, and not just in Germany, is that there are unnatural interruptions of the game which in the end dehumanize everybody involved. They dehumanize the fans because they cannot just enjoy the game anything interesting is happening, the game is interrupted and they have to wait for a minute or longer to see if they can cheer or not. Same with the players. They lose their motivation. If they shoot a goal, they cannot just start and then celebrate. They first have to wait for a minute until the goal is, well, given or not. And it also undermines the authority of the referee to a certain degree. And he's managing the game, but then, oh, sorry, I have to take that back. So that's also true for AI in sports. It has downsides. And if you observe that video, it's from a new table tennis robot launched by Google recently. It's not yet on a professional level, but if you see him compete against these amateurs, I see a similar dehumanizing effect in this video, namely that at least these amateur players lose any sense of, do I have a chance against this machine? Should I practice any further because the machine is apparently so good, I cannot make a point against them. Everybody of them is basically losing. And that reminds me of something, again, the older elders amongst us may have witnessed live in 1997 in, let's call it mental sport. Is that okay for chess? Is that still sport? So that was Garry Kasparov, of course, who lost in a famous tournament in 1997 against IBM's Deep Blue system. And he doesn't seem very happy about his loss, apparently. Now, do you know the story behind it? Yeah, was actually playing quite well in the first game, and then a particular thing happened. The machine played a move where Garry thought, well, that's a really strange move. I wouldn't play that. I cannot see how it can be smart. It looks like a very, very stupid move. But at the same time, he thought, well, it's this world-class computer I'm competing against, which I know plays roughly on my level. It cannot be a stupid move. It has to be a genius move that I cannot understand. So probably I have no chance against this machine because I cannot even understand its tactics. So what Kasparov lost before he lost the tournament was he lost his hope. And that threw him off track with his strategy, as is reported in a book that came out a while ago, and basically made him lose the final match as well, and he lost the whole tournament. Fun element. It later turned out that one move that shoot him off his strategy was a bug in the software that only happened because the machine had a buffer overflow and it actually played a stupid move. But that wasn't the point. The point was Garry Kasparov thinking that the machine is so smart that he has no chance. So why are we talking about all these things? Why is that relevant? I will propose to you that sports is something like a mirror of society. Why? Everybody's enjoying sports. That is one of our favorite hobbies. And people in sports, either on the field or in the audience, are basically from all walks of life we have in our societies. So in sports, we have a microcosm of what we have at large in the population. So what's happening in sports can be seen as a real-world laboratory of what is happening outside of sports. So if we observe what I have called, maybe too strongly, dehumanizing effects of artificial intelligence in sports, then we should pay close attention to it, because something similar could happen to all our other ways of deploying AI in industry, in banks, in education, in the political sector, in commerce, and in our private lives and other hobbies. So in order to analyze this, let's dive a little bit deeper into AI and its effects. What is artificial intelligence? Of course, if you invite a computer scientist and AI professor, we have to come up with some definitions, right? And there are a lot of definitions, and I guess everyone can cite 2 or 3. That's the one that I like, because it has intelligence in it, actually. AI, the mimicking of intelligent behavior with the computer. AI, as I guess we all know, is not about intelligence. Computer scientists, at least, don't have any idea what intelligence actually is or how to implement it as a whole. What we have is this. We have a toolbox. We have a toolbox with a lot of different methods to achieve intelligently looking behavior at the end of it, at the end of the processing chain. We are not creating intelligence, we are mimicking intelligent behavior, intelligent outcomes. We do that use case by use case with sometimes different tools, different methods. One method is quick and clever search algorithms. This was actually the technology used by Deep Blue to play chess against Kasparov. How do these algorithms work? Well, from how the board currently stands, these methods enumerate all the possible moves that the computer system can do, all the possible moves. In every possible move, they enumerate what are all the possible moves that Kasparov could make. In all the possible moves, what are the possible answers by the system, and so forth through the whole game, until they end up at a point where the game is either lost or won, and then they can go back and choose the move that leads to that path. So it's enumeration of all the possible states of the board from where we are. Is that intelligent? Well, arguably, it's brute force, but the outcome is intelligent. It worked pretty well. And if you say this is old-fashioned AI, I would argue with you that potentially many of us used it today when we came here, because it's in all of our route finding algorithms. It's in Google Maps. It's in your transport apps that tell you which train to take and so on. So this is a very modern and very helpful and very much useful deployed AI technology. Well, it's just not the thing that is very cool today. Cool, of course, is machine learning, and especially deep learning. In the last 10, 12 years, there was a huge victory of these methods in a lot of different cases, and most prominently, of course, in detecting cats. Why? Why is detecting cats so important? Well, because it's difficult. Difficult in the computer science sense of that we don't know how to program individual rules that tell us what a cat is as compared to a dog. I mean, think about it. A cat has these whiskers, right? And for a dog, they look different. So that could go into a rule. But what is with a cat that just burned its whiskers? It's still a cat. So we cannot use that as a rule. Same with the fur. A cat has a very peculiar kind of fur, very nice to caress and so on. But you cannot take this as a feature as well, because there are these naked cats, Sphinx cats, I think they are called. You still have to classify them as a cat. So it's difficult to find rules. What do we do? Well, of course, we can take machine learning methodology, which means we take away with all the rules and all our ideas. We take a lot of data, pictures of cats and dogs, the labels, and we let the machine learn how one maps to the other. And of course, mathematically speaking, that means we are learning the functions, or we are tuning the parameters of a predefined function so that it matches our data. Of course, a real function will not be a linear function, a straight line, but something more wiggly, more curvy, for example, in deep neural network. But in the end, it's the same thing. We define the class of function. We give it together with a lot of data to the machine, and the machine tunes all the parameters in a way that the function fits the data, and then we have, hopefully, our solution. That's a principle of deep learning, and we cannot just use it to determine cat from dog. We can use it also to go from a set of words, sentences of words, to the next word, and then we have our large language models, ChatGPT and so on. So that's another very, very important tool from our AI toolbox. Now, what can we say about that result? Well, we can say it's a lot different than we humans work, from all we know. On the basis of how good is it, it's potentially, if the computer scientists have done their job well, on average better than even the best humans are, or very capable humans are. But it can be, in each individual case, completely wrong. That's the nature of statistical models. On average, good, but we cannot say a lot about the individual case. Let me take this animation here as an example for that. What do we see here? We see different two-dimensional data sets, including this nice dinosaur that appears sometimes. And we see a simple statistical model of the data sets here. Just the center point, the mean point, and the spread in both dimensions. And you see that the model is exactly the same up to the third decimal unit for all the data sets. Now imagine we would have estimated this model for a particular data set to use it as a generative model now. For example, we would have estimated it based on the points that make up the dinosaur. And now we want to generate dinosaur points using this model. But we could end up getting these line points instead because they belong to the same statistics according to this stupid model. So even if we trained on the dinosaur data, we could get line data out of it. Because statistically that's correct. In statistical model, what do they give us? They give us statistically plausible results, not necessarily something that we expected or something that is true to any facts, as we see when we use large language models. Nevertheless, these things are very, very useful. Very useful. What I brought you here is an overview of AI applications, generative AI applications. And we see from it that in the area of text, here human readable text, here text readable by computers, computer code, this makes up half of the application space in Gen AI at the moment. This stuff is super useful for text applications, and another quarter of that circle is made up by applications working on image-based data, images and videos. In these areas, generative AI is helpful for a lot of people. Harvard Business Review made a study with people who are working on desks, knowledge workers, and try to find out in which way is it improving the work of the knowledge workers. What we could directly probably think is, well, it will have quantitatively. People will get faster with their job. Well, they also found that they get faster, but the interesting thing is, this here is a quality scale. Harvard Business Review analyzed, do people get better in their knowledge work using generative AI? And they found out that they did a study of people who did not use AI versus people who use generative AI tools. The quality of their work increased significantly from average 4 to average 6. That is really significant, almost 50% plus. So how do people use generative AI in their work? Another Harvard Business Review published story showed 100 different use cases that people have in mind when they use large language models, image generators, large vision language models, and so on. And it's probably too small print to be readable from the second line on, but a couple of them. To generate ideas as a sparring partner to think through things, like the human does the thinking and ask the model, can you give me 10 examples of that? Criticize it, what could others say about it? It's really, really helpful to have these tools as sparring partners just for whatever goes through your mind. People use it also for decision making, is behind the gray bubbles here. Now you can imagine or wonder, how do people use these models with all the stupid failures that they still sometimes have, actually for decision making in large corporations? Think about the following. You can use these models to generate a lot of different responses to inquiries based on certain personal traits that you ask the model to mimic. You can tell the model, think you are a young male student at a university in a big town, you listen to this and that music, you come from that and that background. How would you react to something like this? Okay, you get the response, you file it. Now you prompt the model, think you are a person from a rural area. Your background is this and that. Your parents immigrated when you were 5 years old. You're now working this and that job. What do you think, according to the same text? You get a different response from the same model. Now, if you're clever, you can do that with systematically with, I don't know, 15 different personality traits. You can script it, get thousands of different personas and their simulated responses. Is that the same as making a huge poll on the population? It's probably not the same, but you can do it quickly within 10 minutes, or let's say 5 hours, and analyze the results on the same day and get an idea of what would my business decision of marketing the product this way or that way, how would it be received by these personas that I just simulated? And this way, you can use tools like that also for decision making, and in numerous other ways potentially as well. What could be the future we are starting into, where such tools exist and even become more powerful. When ChatGPT was released November 22, almost exactly two years ago now, my feeling was that this was a moment similar to this. This is Tim Berners-Lee in his office at CERN in Geneva in Switzerland, showing the World Wide Web for the first time to the public. You know, it still looked very, very ugly. You can probably remember small screen resolutions, blinking yellow stuff, animated GIFs, and all the ugliness of the early web. Little did we know then, or few of us, that only 20 years later, or some 20 years later, this ugly technology would become our unified portal to almost all our relationships, because we use it for communication, and to almost all our media consumption, our reading, our newspapers, our books, our other media, our TV. We all do it mediated through the web now. That was not exactly obvious when that young guy showed the web and the first browser. So if ChatGPT is like this, how would that look? Maybe not in 20 years, because this is hard to tell, especially in AI, but let's say in 5 years, plus minus a few, 3 to 5 years maybe. My best guess is that the technology we currently have will lead to something I would call capable personal assistants. And that doesn't mean any artificial general intelligence, AGI. That doesn't mean any super intelligence. I actually think these are profoundly stupid concepts. But I think it will lead to these personal assistants that can help us with all work that can be done digitally. Ordering, that includes ordering stuff online, reserving tables, producing or scanning documents, managing my agenda, stuff like this. How can that happen? I just give you a hint of it because that's not the main focus of the talk. You probably have heard about agentic workflows and agentic designs. The idea is, take your currently most capable large language model, and you know the way it usually works is you give it your prompt, that is all the context, and it predicts directly the most probable next word. That enters the context, it predicts the second most probable word, and so on. And so it writes its text. Basically, if you allow the loose language without thinking, it directly predicts the next output. It doesn't think it through to the end or so, word after word. Which is not the way we usually work when something is at stakes. Example, I am now married since 14 years. There are a couple of questions my wife sometimes asks me, or could ask me, where I know that more thinking is required. For example, if she shows me 2 dresses and asks which one to use. This is not a question of simply, oh, blue is nicer. It's a particular question. You think through the consequences when you're pondering something like this, right? And what could be the result? And then you think further, and after a while you say, go with the red one, for example. And if we would give the same capability to the model, to not directly produce the next word with a fixed number of computations, but produce a draft text that I as a user never see, but that a second instance of the same model sees that has been pre-prompted to criticize it. And then the text goes back to the first model and it can rewrite it. And then the critic can do criticizing again. And if we do that, let's say 1,000 times, that takes a lot of compute, but maybe takes 2 seconds or maybe 10. What I get back is a much better text. If you think this with, I don't know, the next generation capabilities of large language models that still have the fundamental limitations we saw very briefly on the slide with the dinosaur, we don't have any superintelligence, no general intelligence, still stupid models, but it can be helpful on the level of an assistant, especially if these things learn to operate a computer, which is possible within the next 3 years, would be my prediction. So this is what we get, and that would be a very powerful tool. No superintelligence yet, but very powerful. Now the peculiar thing with powerful tools is you need powerful philosophy to actually work well with them. What do I mean? already today, a lot of people are a little bit feeling like our Morpheus here. Morpheus of the Matrix, now I think 25 years old, sitting there being tortured by AI in the person of Agent Smith. They feel like humans are losing out against technology, of not having a chance, not having any hope, like Garry Kasparov probably felt when he couldn't grasp that one move. And that is not a matter of any technical thing we currently see. From all we know scientifically and technically and in reality our AI systems are pretty stupid. And from all we can project, we have no clue of how to make them more smart. We can make them more fast, we can do this agentic stuff, but this is levels below the general capabilities humans have. But people already feel like this. Why is it? Because of worldview. Because of the view of what they think we as humans are, and what they think the machines are or could become. If you want to go deeper into that, Google this new acronym, TASCREAL. It's an acronym for a conglomeration of philosophies, including transhumanism and singularitarianism and effective altruism and long-termism and stuff like that, all isms, all philosophies, all worldviews. If you take these worldviews together, you get a view that has the human not in very high regard and sees technology as basically the natural end of evolution. And that actually makes you feel like Morpheus. So, is there any chance to have hope with powerful technology? And I think there is, if we update our philosophy of who we are and what technology is. There is a chance of having technology and hope, technology with hope. I have brought you 3 hypotheses to arrive at such a worldview. First is, from my point of view, as an AI researcher, stating the obvious. AI currently is a tool. It's not something on eye level with us as humans. It's not a personal counterpart. It's not a you. It's an it. It's something like a hammer, if you wish. You shouldn't view AI as Agent Smith with a face and feelings and needs and wants. You should view it as something that you wield, like a hammer. So for all of us who sell products with AI or who sell research including AI, we should really refrain from elevating it to a position where people could think it's a you, because it's not. And it is creating a lot of fear. Okay, let's go on from this. If we want to take this particular fear out, there are other risks of AI and so on that are real, and we can and we have to deal with them. But this particular fear of the technology, because we think it can overwhelm us, has to do with our perception of what the human is. Why? Because what the human is in the end is connected to what value do we give humans. If you think about it like this, all our liberal democratic constitutions, the Declaration of General Human Rights, all this has been born out of particular perceptions of that humans in themselves have a value that is distinct from what they can do, distinct from their skills, right? We ascribe value to fellow human beings, even if they are severely crippled and cannot actually put any effort into a job or so. We still think they are very, very valuable. Their life is sacred. We have to think about these things to arrive at a philosophy, at a worldview, again, that makes us good wielders of powerful technology. How do we do that? Well, not by technomorphizing humans. If we arrive at a perception of ourselves that basically tells us, well, we are nothing more but a computer, on biological hardware, yes, but in the end, we're doing computations. Human life is about computing. And, well, then we can feel intimidated by powerful technology because, well, the silicon-based computer it doesn't degrade with age. It doesn't forget. It just needs power, and you can add more GPUs and it will run faster, right? So you have no way of not feeling intimidated when you think you are in kind the same as a computer. And I realized amongst my fellow computer scientists that view is actually not too uncommon. It's a very useful tool sometimes in research as an assumption to do certain things, but as a philosophy of life, it brings you into very troubled territory when you're confronted with a technology like AI. And at the same time, it's also not good to anthropomorphize AI, to basically make AI a you instead of an it. Because again, you will have less and less grounds to compare yourself favorably with the technology. So if that's a problem, what do we need to do? I think we need to tell us, humans, again, that we have agency in that world over our own lives and over our future. Because having agency, being able to do something about what's going to happen to me, is what gives us hope. And hope is actually the most needed commodity today. So how can we build that? I think one thing peculiar to humans is that we have to envision the future. We have to see it, read it in a book, see it in an image in order to run towards it. We have to find narratives that are not all dystopian and bad. And if you currently look into any movie, novel, newspaper, interview, most of the narratives about the future with AI are dystopian. Just before I boarded my plane in Switzerland, there was a huge interview by Swiss National Television with Professor Harari, the famous historian from Israel, who was basically telling people like, I'm sorry, there's no hope for the future, we're all gone, AI will overtake governments and that's it. Well, that is exactly the opposite of a positive narrative. He unfortunately missed to mention that that is not due to scientific results, but due to his worldview. So how can we strengthen human worth and value? And I want to end with this. 3 points as well. The first is found in the picture, though I'm not suggesting we should take any example in Star Trek. But did any one of you watch Star Trek as a youth, maybe? A few Trekkies here, that's again the older generation, great. Star Trek actually is one of the prime examples that come to my mind in which powerful AI technology is there, but it's completely in the background. Nobody in Star Trek ever feels intimidated by AI. It's not taking over Starfleet or anything else. It's just there, it's helpful, and it's not dominating the story, even if it's a science fiction series and they had plenty of time to look for whatever can fuel their story. But AI is not fueling the Star Trek story. So obviously it's possible to create narratives to envision a future in which this technology is there, but it's not just not dystopian, it's even not the biggest part. Maybe things humans enjoy, like sports, should play the biggest role. So with this example from Star Wars, how could we arrive at such narratives, which I would urge you to find and create and tell, and so on? Maybe first with an insight. What makes up the human? This is not an exhaustive list. This is just 3 examples found easily, and I found that book quite inspiring, which talks about this and other stuff. So what makes up the human according to this non-exhaustive list? We are beings that need relationship. We are relational beings. We do not work in a non-relational context. There are all these experiments of old and stories where people were, like kids were raised in isolation. It didn't work out. These kids died. We need relationship. We are limited beings. We are quite limited. I guess every one of us today already found some limitations we would rather not have. it's rather aging, or that we need sleep, or that we need food, or that we need to go to the toilet in the worst moment, or whatever, that we cannot work on all the emails we get every day. We are limited, which is really, really annoying. But as several people, for example, recently in a book, the DeepMind professor of machine learning in Cambridge, Neil Lawrence, pointed out, it somehow defines who we are. It even profoundly shaped our intelligence, which is not general intelligence, but very, very special. Just an example of what I mean. Even what we enjoy is coupled to these things being limited. We as people enjoy stuff that is scarce. Like, if you read the memoirs of people who had all the sex they wanted in their life with all the different partners, or all the money that possibly a person could earn, or all the other material things, these people uniformly tell you that in the end it was not fulfilling. That what you can have as much as you want in the end is not what you want. Somehow limitedness is important to us, as is to have responsibility on something. You could even put it like this: we seem to be created to be kings in some realm. And that realm might be as little as my own body and my own destiny, and it might be as big as leading an organization or a country or whatever. But somehow we seem to need responsibility over something. The most dehumanizing thing you could do to any of us is to rid people of all responsibility, even over themselves, to not be able to determine where you sleep, what you do, when you get up, when you go to sleep. That's slavery. That's really, really bad. So we need these things. These things, and possibly others in addition, are defining who we are and what we are. They are making up the human. So with this insight, I suggest the following thought. Why not use technology, and also our most advanced technology, also AI, to strengthen these specific human traits instead of undermining them? That would be something that in the end should make us not just more efficient for a specific situation, but feel more at home in these bodies and in this world and in this society. An example, like the last few years as my job and my career developed, and more responsibilities were added, which is great for being human and so on. Also, I had to work on my efficiency to get all the work done and still have a life next to it. So I was looking for many, many different ways of how I can become more efficient at what I do. Can I answer more emails, have more meetings, supervise more students, lead a larger organization, grow the organization, have additional side jobs, write more papers, and so you know the game. I became pretty good at that. I'm now on sabbatical leave from my job since 4 months and for 2 more. And what I already learned is that while that was all amazing and cool, what came out of it, with a little distance to my daily business, not everything of what I'm doing there actually contributes to my humanity and my well-being. And if you wish, all these AI tools and AI tools, some without and some with, that helped me to become ever more efficient, didn't contribute much to me becoming a better person, or a better father to my 4.5-year-old son, or a better husband, or a better boss, or a better supervisor. If you wish, maybe the spam filter that not helps me to write more emails in shorter time and even have more contacts and projects, but that filters out a couple of stuff that is too much to read anyway, and rids me of additional things that would not contribute to my well-being, is the most ethical AI application ever. Maybe we should direct our technologies at these things that not make us more into robots, but more into humans. So, to finish this, I guess the biggest fear associated with AI shouldn't be that machines take over, because there is no machine yet that could do that, and it's arguable if there ever will be. The biggest fear is us voluntarily dehumanizing ourselves by giving up our freedoms, yielding to machines, feeling intimidated, and so on. So the best thing we could do is to explore this technology and explore uses and write narratives around using it for our humanity. And why not foremost do that in sports? See if that works, see where it works and how it works, and bring it into society as a whole. Thank you very much.